See gentlemen, good afternoon all of you. Today I would like to discuss a relation between electric current and drift velocity. See, we are already familiar that what is the electric current. Electric current is nothing but the rate of flow of electric charge, that is nothing but the electric current. Similarly, so we have to know that what is the drift velocity. It is the average velocity with which free electron get drifted towards the positive end of the conductor under the influence of external electric field. This is what the definition of the drift velocity. Drift means displacement, is it? See, as you know that, so AB is a conductor of length A and its cross sectional area is A, or area of cross section is A. So as you know that in this cylindrical conductor there are so many free electrons are there, or conduction electrons are there. These conduction electrons, they are randomly in zigzag way, they are moving inside the conductor. So simply according to the definition of electric current, that electric current is nothing but the flow of electric charge. You are calling that electric current. Simply if the charge they are flowing from one point to another point, they won't constitute the electric current. So in order to constitute the electric current in the conductor, there should be net flow of charge in a particular direction, or net transport of electric charge from one point to another point in a specified directions, which defines the electric current. So here, before applying the electric field, so in this conductor at room temperature, the conduction electron they are moving zigzag manner inside the metallic conductor. So say that in 1 second, some say that from B end to A end, say 100 electrons they are shifting from B end to A end. At the same time, 100 electrons they are moving, shifting from the A end to B end. So 100 minus 100, 0. Net flow of charge is 0. So that means that simply flow of electric charge, it doesn't mean that which constitutes the electric current. If the flow of charge move in a specified direction, which constitutes the electric current. So now, as I said it, we are consider a conductor. AB is a conductor of length L and whose cross-sectional area is A. So now simply by considering the conductor, we can't maintain, we can't generate, we can't produce the current in the conductor. In order to establish the current in the conductor, you have to satisfy the three conditions. First condition is that there should be a conducting path. Of course, this metallic conductor, it is a good conductor of electricity, is it? Second thing is that, so across the ends of the conductor, there should be potential difference. So here, there is no potential difference. So therefore, inside the conductor, electrons are moving in a zigzag manner. So therefore, in order to give the definite orientation and different direction for the flow of electric charge, so you have to establish the potential difference across the ends of the conductor. So in order to establish the potential difference across the ends of the conductor, so you have to introduce a battery. So this is a battery, is it? So now with the help of this battery, we can able to form the potential difference across the ends of the conductor, is it? As a result, whenever the potential difference form, electric field is going to form. So electric field is nothing but a force which drags the electrons towards the what that negative, that electron, they are dragging, they are shifting from the B side to A side. So that means that all the electrons they are dragging towards the, as soon as you close the circuit. So as soon as, say that this is an imagine that there is a plug key. So this key will be work as a switch on and off of the circuit. So as you see that, see this is on a positive side, positive, and this is the negative. So electron they are dragging, shifting as soon as you close the circuit. So electrons from the B end they are shifting towards the positive end of the conductor. While shifting inside the conductor, what happen that they will interact, collide with the some atoms. So even though they will move towards the A. As a result, electric current will going to constitute in the this metallic conductor. Let us see. So I would like to discuss about the whatever that circuit as I designed. The same circuit I will describe it. Consider a consider a cylindrical conductor, or consider a metallic conductor of shape cylinder whose length is L, and cross sectional area of cross section is A. So we are consider AB is a conductor whose length is L and its cross sectional area is denoted by A. As I said it, simply by considering the conductor, you can't establish current in the conductor. In order to establish the current in the conductor, in order to produce the current in the conductor, so you have to satisfy two conditions. First condition, there should be a good conductor of electricity. I mean that this cylindrical conductor, so shape of cylinder, this cylindrical conductor, so what it does, so it contains the free electron. It will going to act as a good conductor of electricity. It is a conducting path. So now because of this battery, so a PD will going to develop across the ends of the conductor. So whenever the PD is formed across the ends of the conductor, as a result the charges they are dragging, I mean that electron from the B end they are dragging towards the positive end of the conductor A. So all the electrons they are dragging, they are moving in a specified direction. So it is as I would like to be an analogy. So in the see that before applying the battery, before connecting this battery to the circuit, what happened that the electrons they are moving inside the conductor in a zigzag manner. So just like fishes are moving inside the ocean in a zigzag zigzag manner. There is no specific direction for the movement of the fish. So in order to give the specific direction for all the fishes, so if you drop some footstep in the ocean, what happens that in order to catch the footstep, all the fishes they will move towards the footstep. Likewise, as soon as we are connecting this battery to this conductor or a cylinder, so electron they will get in a specific direction. They will start to move in a specified direction. Whenever the charges they are moving in a specified direction, As a result, electric current will going to constitute in the circuit. Electric current will going to generate in the circuit. So that means that so this is what as we are connecting battery. So as a result, electric field is going to develop, or as a result, potential difference will going to form. Because of potential difference, electric field is going to set up in the conductor. So electric field is going to act in this direction. Electric field is going to act in this direction. So this we can say that E represents the direction of electric field, whereas the flow of electron is opposite to the what? Electron. So E represents the flow of electron. So electron, they are flowing from the what? Negative end towards the positive end of the what? Conductor. But electric field is going to move from the what? Positive end of the conductor towards negative end. So in this way, this is the direction of electric current. So as you know that, so since we are connecting battery to this circuit, say I ampere of electric current is going to generate. As soon as we are connecting the battery to the circuit, electric current is going to generate in the what? Circuit. So as I said, we are consider a metallic conductor of shape cylinder whose length is L and cross-sectional area, cross-section area of cross-section is A. Now say that in order to drag the electron in a specific direction, so what you have to do that, you have to apply certain PD by connecting battery to this circuit. So before that, you have to find out that what is the volume of this conductor. Volume of the conductor, as you know it, volume of the conductor. So it looks like cylinder. So you are already familiar that conducting rod, it looks like a cylinder. It is a shape of a cylinder. The volume of the cylinder, as you know it, so that is what is that? Length into cross-sectional area, which gives the volume of the conductor. So that means that volume of the conductor, so which is nothing but the length into cross-sectional area. L represents the length, cross-sectional area, which is represented as AL, which gives the volume of the conductor. Now, so in this conductor, say that the length of this conductor, imagine that it is 100 centimeter. This length of the conductor, hypothetically, so you have to imagine that it is divided into equal 10 segments, 10 part. So that this is among the 10 equal part, you will consider one of the segment. This is the first segment. So in this segment, you have to see that how many electrons, free electrons present in this segment. Say 10 electrons are, imagine that there are 10 free electrons are there in this segment. Similarly, in the second segment, 10 more electrons. Third segment, 10 more electrons. So that means that total number of free electrons present in the conductor is, that is 10 into 10, that is 100. So that means that you have to, so first of all you have to know that density of electron, that number of electron, n represent the number of electron per unit volume of the conductor. Per unit volume means you have to consider a small segment of the conductor. In that segment, you have to note down that how many electrons are there, how many charges are there. Say for example, as I said that, so n represent the number of free electrons, number of free electrons per unit volume, free electrons per unit volume, of the conductor. So n represent the, that what it means. That in unit value, how many number of electrons are there? That is what the meaning. Now let me know that. So how many electrons are there? Total number of free electron present in the conductor. Total number of electrons. Therefore, total number of total number of free electrons, total number of free electrons present in the total number of free electrons present, total number of free electrons present in the whole conductor, whole conductor, which is equal to n times Al, which is these many number of electrons are present inside the what cylinder, inside this conductor, these many. That in order to find out that how many number of free charges are there in the conductor, so with this expression you can find the number of electrons present in the conductor. So now each say that E is the charge on each electron. Let E is the charge on free electron. Let E is the charge on each free electron. So what it represents? E represents the charge on each free electron. So how many electrons are there? Total number of charge present in the this conductor, which is having length L. So that means that total free charge in the conductor, total number of free, that total charge of the I can say that C, let E represent the charge on each free electron. So you have to know that C, total charge in the conductor, total charge in the total charge of the electrons in the conductor, total charge in the conductor, total charge of the electrons, in the conductor, that is equal to what? E times of this, that is E into NaN. With this expression, I can total charge of the electrons in the conductor or total number of charge. Otherwise, you can total charge of the electrons in the conductor is this, is it? So you total charge, that is nothing but the Q, that is Q is equal to, that is you can say that Q is equal to NeAl. So you can call it, this is an expression 1. Now, say that in order to drag the electrons in a specific direction, as I said that, so you have to apply the potential difference. Say that you are applied that let V be the potential difference PD applied across the ends of the conductor, If it is the case, what happens that? So as a result, whenever that you are applying that certain PD or this conductor, as a result, as a result, as a as a result, electric field setup, electric field setup inside the conductor. So due to which charges begins to move towards positive end. So that means that electric field setup in the conductor is given by, so therefore electric field is given by, so E is equal to, so E upon L, where we represent the potential difference which is applied across the ends of the conductor, where the L represent the length of the conductor. So as I said that what is the consequence of electric field? The consequence of the electric field is that it drags the electrons or charges towards the end A. Is it? Say that so in order to cross all the electrons from in order to cross the, or time taken by the electron to cross the otherwise you can say that time taken by the electrons to time taken by the electron to move all the electron from A to B is given by, or time taken by the time taken by the electrons to cross the conductor, to cross the length L of the conductor. So if it is the case, so as you know that, so what is the velocity? So you know the definition of velocity. Velocity is equal to distance upon time. So where t represents the year, so Vd represents the drift velocity and t represents time. Distance is nothing but the L. So L upon tau. So with this expression, so time taken by the electrons to cross the length L of the conductor, which is nothing but the tau is equal to L upon Vd, where Vd is nothing but the drift velocity. It is an average velocity. Drift velocity means it is an average velocity with which free electron get displaced towards the positive end of the conductor under the influence of external electric field. So whereas L represents the length. With this time, all the electrons, they are moving from the end A to end B. Time required to cross the electron from the B end to A end. Time taken to move the charges from B to A, that is nothing but the tau is equal to L upon Vd. So this you can call the equation 2. So we are already familiar that. So this definition of electric current. So we know that we have from the definition of electric current, from the definition of I can write it as I is equal to Q upon T. Q upon T, you can write it as Q upon tau or T. You can write it as T itself. See, now this you can call that equation 3. So you see that what you have to do that. So only thing is that in order to bring an expression for the I, you have to substitute that total, total number of charges, present in the conductor, that is Q, and this, that equation 1 and 2 you have to substitute in equation 3. From substituting 1 and 2 in equation 3. So I am doing what happened that substituting equation 1 and 2 in equation 3. So what happened that, so I is equal to Q is nothing but this, that is N times E A L. So similarly, time expression is L upon Vd. So this L will get cancelled. Finally, we will get an expression for that is the Vd will go to shift it to the numerator, NEA Vd, or you can say that I is equal to NEA Vd. So for the given conductor, what happened that for the given conductor, so this is constant, this is also constant, cross-sectional area is also constant. For a given conductor, a specific conductor, these three physical quantity will be constant. So for the given conductor, so given conductor N, E and A are constant, that is I is directly proportional to Vd, that is the electric current flowing through the conductor is directly proportional to ultimately